Hello, dear students. So this is another lecture on this. I cannot say this complex analysis. So today's topic is about that those beta and gamma functions. So you are familiar with the if you so in our class during our classwork, so we have discussed about the different properties of those beta and gamma functions and some more and also the nature of that gamma function. So how we get that gamma function, how it behaves like it. So if you write that gamma function, so it basically resembles the Gaussian distribution, right? And so we have already discussed about those what are basically the gamma functions. And today's topic is so that's about if you want to this verify the following identities. So first identity is that is so B, it basically B stands for the beta function. So we have beta function. We can express this beta function in terms of that. You can write the integral representation of the beta function, and so we need to prove this identity that beta of a b equal to this thing, right? So but if you remember that in our classwork we have already discussed about what is the relationship between beta and gamma function. So if you remember that this gamma function, it is metamorphic function because it has finite number of singularities which lie on the negative real axis. And what about this beta function? So it basically the nature of the beta function is not well defined compared to that gamma function because gamma function is metamorphic function. So we have well defined those singularities on the negative real axis, right? So we can say that it is continuous, but piecewise it is continuous, that gamma function, right? Now, so that means so we are already aware about the different properties, or we can say that the different properties of those gamma functions are known to us. So that means instead of that, we can relate that beta function with the gamma function by the relation. If we have that this beta of n, so that's equal to gamma n, gamma n. So this is the relation how you can relate this beta function with the gamma one, right? So that means we need to prove this identity that beta of a b equal to this beta of a plus 1 comma b and plus beta of a comma b plus 1, right? So we can use this property, right? So that means instead of that, so if you use this property, so instead of this, I can rewrite this as, so this will be mn then. So I can put instead of this, I can put mn n value. Okay. So it will be that a plus b, a comma b. This will be a. Okay. Now let us prove this identity first, right? So we have four identities. So actually, I'm taking this problem from this Arapkin and Weber. So I don't remember exactly what is the page number, but it mentioned that we have four identities of these beta functions. So we can use it. So we can use this property of this beta function. How you relate this beta with the gamma function? And first, if you take the left hand side, so if you rewrite this as, so that means this beta of that a plus 1. तो अगर इसको मैं लिख सकता हूँ, I can rewrite this as, because instead of that a plus 1, instead of that a we have a plus 1 and b same. So I can use that beta of mn. So instead of that a we have a plus 1. So this will be equal to, that will be equal to gamma of a plus 1. So this is basically first term. So इसको मैं लिख सकता हूँ ना, because you are already familiar with this relation. So beta of a plus 1 will, it will be beta of a. So instead of a we have a plus 1, gamma of a plus 1, and gamma b divided by gamma of a plus b. So instead of a we have a plus b. So we can write that a plus b plus 1, right? So this was first term. And similarly, if you rewrite the second term, so that will be equal to, okay, let me write it here. So instead of that, I can rewrite it here. So I can rewrite this as, so that means we need to write that because that beta of a plus b, beta of ab is equal to that is gamma a gamma b divided by gamma of a plus b. So instead of this, so second term हमारी आएगी, that will be gamma of a. So gamma of a is this one and gamma of b, because instead of b we have b plus 1 and divided by that gamma of a plus b. So gamma of a plus, instead of b we have b plus 1. So this is same, right? So if I take, because our denominator is same, we have this gamma of a plus b plus 1. So I can rewrite this as, so I can rewrite the gamma of that. This same thing, okay? And in the numerator we can have that gamma of a plus 1 gamma b. Okay. So what's our next step now? Because I can rewrite this as, so if you remember that, so when we discuss that gamma function, so we can have this gamma of that z plus 1 equal to z gamma z. So let's use this relation. So that's gamma of that a plus 1 is equal to a gamma a, right? So I can use this property in this equation. So we can rewrite this as, so instead of z we have a here, so it will be a gamma a, right? So this will be equal to a gamma of a. Okay. Now we can write that, because in the numerator we can take that gamma a, gamma b common. So inside will be, that will be a plus b, because we have b here, because you can use this property again, that gamma of z plus 1 is z gamma z. So I can use it, this property, to this gamma function, that's gamma b plus 1. So it will be b gamma b. So this is what I wrote here, b into gamma b, right? Now from in the numerator, so numerator से मैं क्या लूँगा? I can take that gamma a gamma b common, so inside will be a plus b. So that means I can rewrite this as, right? Okay. So I can use that, because we know that that gamma of that z plus 1. So again I will use this property. So instead of z, so z is our, that's a plus b now. So denominator. So let us write this denominator in this form, because our denominator is, that's a plus b plus 1. So that means जो हमारा a plus b है, that's our z here, right? So this will be a plus b gamma a plus b, because using this property gamma of z plus 1 is z gamma z, right? So that means I can rewrite this as, so this will be equal to that gamma a. Okay. Now this a plus b cancels, so you can write this as, because this a plus b will cancel. So in the numerator we have gamma a and gamma b, and in the denominator we have gamma a plus b. So ये किसके बराबर है? That's our beta function. That is because beta of ab is. So if you check that, so how we can rewrite this as? Because we can write that beta of ab, that's gamma a gamma b divided by gamma a plus b. So that's our right hand side. So that means we prove that this beta of a plus b comma b plus beta of b of a comma b plus 1, it is equal to b of a, right? So this was the first identity, because, so this is clear from here. Okay. So because this was our left hand side, so it comes out to be equal to the right hand side. So this was the first identity of the beta function. And similarly, if we check one more identity, so if we have this, so we need to write that b of AB, so that's equal to, okay. So this is on another identity. We need to prove that b of AB we can write as that beta function can be written as a plus b by b into b of a comma b plus 1, right? So, so again we will take the left hand side. So taking LHS. So we can rewrite this as that's a plus b. Okay. So again use the property. We know that this beta of AB equal to, okay, because we have this beta of AB equal to gamma a comma b divided by gamma of a plus b. So we will use this property here. So we can rewrite this as, so this will be equal to a plus b. Okay, or you can rewrite this as, right? So यहाँ पे मैंने क्या किया? So again use the property that gamma of z plus 1 is z gamma z, right? So because this is gamma b plus 1, so this will be b gamma b, right? And similarly in the denominator, तो जैसे मैंने first identity में किया था, so again we will choose that this will be our that z, so gamma of z plus 1 is z gamma z, so z is our a plus b, gamma of a plus b. Now this a plus b, this side a plus b, this will cancel, and this b and this b will cancel. So we can rewrite this as, so this will be equal to that gamma in, so that's equal to, so this was our left hand side, right? Because I take that left hand side, so we solve it, so it comes out to be equal to beta of AB. So that's our left this. Sorry, what I take the right hand side. Sorry, right? So I take the right hand side. Huh? So this is equal to that right hand side. So when the right hand side here, so we prove that right hand side equal to the left hand side. So because B of AB is our left hand side. So this was another identity for the beta function. And similarly, we have one more that this this identity, that is basically if you want to prove that B of AB, so that's equal to B minus 1 upon A. Okay, so we need to prove that beta of AB will be equal to B minus 1 by A, beta of A plus 1 into gamma B minus 1. So this was, so we need to prove that left hand side equal to right hand side. So again I will take my right hand side, so taking RHS. So that is B minus 1. Okay. So again I will use that beta of AB, that's beta A beta B, that's gamma A gamma B divided by gamma A plus B, right? So use it here. So this will be equal to, better is to write it here because I cannot write everything here. Okay, so this will be equal to okay. Just check it because beta of AB equal to beta gamma B divided by gamma of A plus B. So instead of that, instead of A we have A plus 1, so this is gamma A plus 1, and instead of B we have B minus 1, so gamma B minus 1 divided by gamma of A plus B. That's A plus 1 plus B minus 1, right? So this is very clear. Now again use the property that gamma of Z plus 1, that's Z gamma Z. So use it here. So this will be equal to, so we can rewrite this as B minus 1 upon A, that's A gamma A, right? And this is gamma of B minus divided by, that is gamma of, right? Now we have this A and A will cancel here, and we can rewrite this as, so this will be equal to that B minus 1 gamma A gamma B minus 1. तो डिनोमिनेटर में क्या आएगा because gamma B plus A, right? Now what's now in the numerator? So this relation. So we have this. So if you remember that this gamma of Z plus 1, that's equal to Z gamma Z, right? Okay. Or you can rewrite this as if you shift that Z to Z minus 1. तो अगर मैं यहाँ पे Z के बदले में लिखूंगा Z minus 1, so this will be gamma Z, that is Z minus 1 gamma of Z minus 1. Is it okay? Because gamma of Z plus 1 is Z gamma Z, so I will shift that Z to Z minus 1. तो यहाँ पे बनेगा because it will be Z minus 1 plus 1, so it will be gamma of Z. तो Z को मैं shift कर रहा हूँ to Z minus 1, so it will be Z minus 1 gamma of Z minus 1. So this is our that. So you can, so that means instead of this term, so this is B minus 1 gamma B minus 1. So this is same thing, that is Z minus 1 gamma of Z. So it will be gamma of Z. So that will be gamma of B, right? So using this property, so that means I can rewrite this as, so this term will be equal to B minus 1 gamma of B minus 1 because it is symmetric. So you can, because we know that this beta of AB equal to, so that is gamma M, gamma A, gamma B. So I can rewrite this as, it will be that gamma B, gamma A, gamma B plus, right? So this is equal to beta. So that means our beta function is symmetric also. So because you can write that gamma A, gamma B as gamma B, gamma B, gamma B, gamma A divided by gamma B plus A, right? So that is B of AB, beta of BA. So that means this is symmetric, right? B of AB equal to B of BA, right? So you can write that. So that means this is our because B of AB equal to B of BA equal to B of AB, right? So it is symmetric, that beta function. So but this is our left hand side because तो हमें क्या prove करना था? If you check, so we need to prove that beta of AB equal to this one. But we take that or this right hand side, so we prove that we prove that our right hand side equal to that is equal to left hand side, that is B of AB. So this is what we prove here. So that's equal to B of AB. Yeah? At this. Okay. So, so there is one more identity. So this B of AB here. So there is one more identity, the last identity. We have to prove that. We need to prove that B of AB. तो ये हमें प्रूव करना है. So that is equal to. So we need to prove that this is equal to that. So ये हमें प्रूव करना है. That is B of AB into B of A plus B into C. That's equal to this thing. So we need to prove it, right? So you can do one thing. So let's do. You can take that left hand side, or you can take this right hand side. That should be equal to left hand side. So I will take this time. I will take my left hand side. Huh? So take left hand side. So what's my left hand side? So left hand side is that is beta of AB. So using that property, so B of AB equal to gamma A gamma B divided by gamma P plus B. So this will be equal to, it will be gamma A into, that is, तो इसके लिए भी I basically express that beta function in terms of that gamma function. तो पहली वाली जो term है that is beta फिर that is gamma A gamma B divided by gamma P plus B, and now second this beta function that is beta of A plus B comma C, right? So that is equal to gamma of A plus B, because in the stop A we have A plus B and that gamma C divided by gamma of A plus B plus, because A के बदले हमारा है A plus B and B के बदले हमारा C, right? So this is what we, so how we can write it? So instead of that we can rewrite this as, so because I will write now, because we need to prove this should be equal to beta of BC. So beta of BC अगर इसको मैं gamma function में रखूंगा, it will be that gamma B gamma C divided by gamma B plus C. So that means I will write here from, first I will write the, because it is symmetric, right? So B of A B equal to B of B. So I will write the gamma B from here, then gamma C from here, right? Then I can, okay, let me write it first, right? So I will rewrite this as, so first term will be, that will be gamma B and gamma of that A plus B. So can we write it? तो जरा चेक करो. तो यहाँ पे मैंने क्या किया, instead of this पहले मैंने लिखा गामा बी एंड देन गामा सी, तो डिनोमिनेटर सेम है, दैट इज गामा ए प्लस बी, देन गामा ए एंड गामा बी प्लस ए प्लस बी, a plus b, right, divided by gamma of a plus b, a plus b plus c. So this is what we wrote. So what we write here, right? Okay. Now, so can we cancel something, because this gamma of a plus b, this will cancel with this, because we have one gamma of a plus b in the numerator and denominator, right? So this and this will cancel, right? So we can have, so we can write this as that gamma b, gamma c, okay. So how we can write it now? So I can rewrite this as, so this can be written as that is gamma b, gamma c, and gamma of that into that. तो यहाँ पे मैंने क्या किया, जस्ट चेक। तो यहाँ पे मैंने क्या किया, बिकॉज देयर वाज वन इन द डिनोमिनेटर, तो यहाँ पे मैंने मल्टीप्लाई एंड डिवाइड किया किससे, गामा बी प्लस सी, तो वो गामा बी प्लस सी मैंने यहाँ पे रखा। तो रेस्ट इज सेम, दिस वाज गामा ऑफ ए, then gamma b plus c, that gamma b plus c is here, right? So this will cancel, so we will get the same term, and so this gamma a plus b plus c. So if you check this term, so this is gamma b gamma c divided by gamma b plus c, it is that is b of bc. तो इसके बाद मैं लिख सकता हूँ, this will be b of that bc, that is beta function, right? So because this is b of bc, that is gamma b gamma c divided by gamma b plus c. So this is first term, and second term क्या आएगी? So it is gamma a gamma b plus c, gamma a plus b plus c. So it will be b of a comma b plus c. So this will be equal to b of a comma b. Right? So this was, तो शायद हमें यही प्रूव करना था. So we need to prove that b of b plus bc comma b of a comma b plus c. So because we need to prove this, our left hand side equal to this thing. तो हमें प्रूव करना था ये आना चाहिए इसके बराबर. So that is beta of b comma c, beta of a comma b plus c. So let us check. So we are getting the same thing. So just check it here. Okay. So that is beta of bc comma beta of a comma b plus c. So these were some of the identities of these beta functions, and similarly we can prove some more relations on some more properties of these beta functions, just what we did in our classwork, like Riemann zeta functions, and also there was one more function, I don't remember its name. And we can also do some so we can also do some problems on the Stirner's formula. So maybe we have discussed a part of that Stirner's approximation, right? So I think, so if it will be possible, so we can do some more these problems, or we can do some exercise on these beta functions or gamma functions also, right? Thank you very much.